So some of the questions that were asked in the assignment for both assignment 1 and assignment 2, look, I try as much as I can to be specific in the questions that I ask. The assignment that you've done to these assignments 1 and 2 has been developed from one of the previous exam papers that I set up. So these questions were externally moderated as well. Okay. So it gives you some sort of idea of what the exam would look like. You're not going to be asked the same questions, obviously. You're not going to have the same data set, obviously. You're going to get new data to work with. But the general idea of what we want you to learn in this module is encapsulated in your take home exam. So, my preferred version of R, it doesn't matter. You work with what you are comfortable with. Okay? As long as it is, look, you're not supposed to do calculations and stuff in Excel, right? The point is not for you to learn Excel. The point is to use R so that you have some coding background. And I understand that everybody comes from different backgrounds and everybody has different levels of coding under their belt. But everybody has not got the same level. And so the choice for us to use R was it's the next step after Excel, right? In previous years, we taught this module in Excel, but now we feel like at least R needs to be known by everybody because it's important to learn a language. And so base R is the sort of the base level of your coding, right? Whatever you do after that or whatever you have done as well, that is all well and good. But for this 713 module, base R is the preferred language to use. So that is the one that the memo will be written in. That is the one that I will use as my marking solution. That is what the moderators have as well. And should we change it in future? That's a discussion for another day. But we find that this is the first stepping stone in your coding career. Whether you have coding background or not, this should be the first step, especially for statistics. So this is a statistics module, right? And even though we are more emphasizing on the visualization part of it, the statistics and the theory behind the statistics is what is important as well. We want you to learn the statistics. So, for example, when you're performing an hypothesis test, you have to start an hypothesis test with your null and alternative hypothesis. Okay, so that is very important. You have to use your statistical notation. If you don't know how, you have to learn. So that's a skill that you're going to have to learn. I can show you how to create a formula in Word as well, so that when you are writing your report, you know how to use those functions. So these are all things that I'll while we're going through the actual assignment questions, I'll bring up a few points that I've written down that I want you to remember and practice and use going forward for your exam. Okay, it's just overall things that I've noticed is quite important and will help you to have a better experience when you're writing your exam. So coming back to the point that I was making, where these questions were moderated, right? So these questions were internally and externally moderated. Um, and the idea is to give you an overall um, strategic plan, I would like to say, of what to do when you start handling data. Okay. And so the assignments that we give you and the final exam, it is sort of going to give you a global idea of where you're starting with and how it evolves when you actually need to go through the steps of working with data. Now, this course cannot cover absolutely everything that you're going to learn in statistics and all the steps that are involved, that actually needs to take place when you're working with real data and you have a research question that you're trying to answer. So, for example, data cleaning, that is not something that we focus on in this module, but it is a very large portion of your steps that you need to follow in your methodology when you are busy working with raw data. Okay, so that you will learn how to do in one of the next modules that you're going to do. I think in 715, they'll start teaching you how to do some data cleaning. So, what does data cleaning mean? When I give you data right now, the data has been cleaned already, right? So you don't have things like missing values, you don't have anomalies, you don't have um, an anomaly could be a misspelt word, something like that, missing values, and how to do imputations and things like that. If you have data that is skewed, what to do with that skewness, how to handle it. When you have categorical variables and you have outliers, how to handle that. When you have numerical data and you have outliers, how to handle that. Those are all things that are involved when you have data cleaning. How to do, like we start with cross-sectional studies. We just touched on that a little bit. We do scatter plots. Those are all things to identify if certain variables have anomalies in them. And then the next step would be what approach you need to follow in order to clean that sort of data. So that is a big chunk of the work that is left for another module, right? So when you get your data has been cleaned already. So we want you just to focus on the visualization portion of that, but not forgetting what the statistics is behind that visualization portion. So when we say descriptive statistics, what do we mean? When we say summary statistics, what do we mean? When we say all these little terminologies or concepts, you have to go through your notes. You have to read through your textbook. You have to go through the slides if you want to, and go check what are the descriptive statistics, what are the summary statistics. Because when we ask you questions, we are not going to explain to you what do we mean. You need to understand the concepts of statistics by now already. Okay, so when we ask you certain questions, we expect a certain level of understanding from on your part because you have now gone through two assignments and you have gone through some theory questions online through some testing, but also you are doing your own research. And what was pleasant to see with both of your assignments was that even though you didn't know how to do certain questions, you did some research behind it, and I could see everybody did different kinds of research. Everybody tried to answer questions in their own way to their own understanding, which was awesome because that's all that you can do, right? To your understanding, your level of understanding, and how you followed using the code that you've learned, how to do that, how to answer questions, and things like that. So, the pointers that I'll be giving tonight on Thursday will sort of just help you go the next step to make your submission. And it's not only skills that I want you to learn for this exam, it's skills that you're going to hold on to and carry on with those skills in the next semester for all of your modules, but mainly for the statistics one. And then next year when you have your project as well that you need to complete. Okay, so I hope that it's going to help you in some way. But let's get on with it. So, one of the first things that I wanted to tell you was when we say you need to use R, you actually need to use R. Don't do your calculations in Excel. Excel should be used for making a table look pretty. Okay, that is as far as Excel needs to be used for. So, for example, in your first assignment, when you had to do a frequency distribution, those columns, you have the code for all of those columns, your relative frequency percentage, cumulative frequency, relative cumulative frequency percentage. You have the code for all of those things. So the expectation is that you use R to do that, and then you copy those output into your table, and then you use Excel to make your table pretty so that you can paste that into your report. Okay, so the second thing related to pasting, when you have, so I'll just give you some general notes and then we can go into the actual questions. When you're doing your actual copying and pasting, there's certain copying and pasting that is not allowed. Not that it's not allowed, but it's not the best option to use, right? So you're not going to do a screenshot of your code. When you have code, let's see. Okay, I'm going to just share my screen. I don't have any code in my R now. Okay, I'm just going to share my screen quickly. Okay, so let's say, I don't know. Okay, let me just see what my sample looks like quickly. Okay, so let's see, this is my sample, right? I now want to copy this code over into my appendix. I am not going to do a screenshot. So if I do a screenshot, okay, I don't know who else has got this option, but let's say this is your option. And this is I'm going to open a Word document. If it will work with me. Sorry, my paste. Is everybody still here? Okay, so this is now, I copied my output or my code here, right? Let's say this is the question and this is my appendix and this is what I'm doing. So this is not what we want to see, okay? Because firstly, it takes up way too much space. Secondly, you tend to have a picture here, a picture here, a picture here, and it's all different sizes and different shapes and different. So sometimes I can see what is written here, sometimes I can't see what is written. Sometimes I have to zoom so much, and I already wear spectacles when I'm looking at my computer, so I can't see very well. And it gets frustrating when you're trying to sort of understand what steps you followed, but you can't see them very well. Okay. So instead of doing that, I know it saves you time, but that is, you're going to, for an exam, you're going to be marked down for that, because it's not only me that marks your paper. We have an internal moderator that marks your paper and an external moderator that marks it. Okay. So what we want to see is, I want to see all of this. So I want to see your code, which says that's in red, and I want to see this output over here. Okay, so in terms of saving space in your appendix, don't think this part is less important. I need to see what your code is giving you, because one, I know that you didn't copy it from somebody else. Two, you didn't copy the code off the internet, and I can actually see if you're making an error when you say there's something here and you write it out in your report and then it's something different. Okay, because that has happened in assignment one and assignment two with different people, where you have some output here, you copy it over into your report, and then it's two different values that you are reporting. So you're going to highlight both of it. Control C for copy. You're going to go to your document. This is now going to be in the way. And then I'm going to paste it over here. So now you'll see that this is not in the correct font that has been requested in the instructions in your exam. So you're going to highlight it and you're going to go to font and you're going to change it to Courier New in font 10. Okay, so it's important. This is what we want. And do you see how it has changed what the table looks like? All of that, everything is now being aligned properly, okay, to how it looks in your actual code. And so that is what we want to see. I want to see everything, and nothing should be in red and in blue, because when I mark, I'm going to mark in red, and when the moderator moderates, they mark in green. Okay, so it's important that you don't have this, because it is confusing for the marker to see what is your code and what is something that I have written that is part of my marking. I'm sure you've noticed by now in your documents that I've sent back to you, I do make notes so that you can read and understand where my thought process is. So that's important that I want you to remember. Don't use red and don't use green. Just copy it over like this and paste. And then you're going to go to the next one. So before this, you're going to say question 1. And then this will be question, or not question, let's say 1.3, for example. And this you're going to make in bold so that we can see this is a different section from what the next section is going to be. So when you get here, you're going to have 1.4, for example, and then you're going to do this in bold. Okay, if you want to, you can say next under this. I'm sure you've looked through my my code for assignment 1 already. So you've noticed that this is what I do. This is just going to say check variables in sample, something like that. I'm not saying you have to do this part, but you have to definitely do question 1 and 1.1, 1.4, 1.5, whatever, and divide those sections up so that we can see where the differences are. Okay, what code refers to what question, and that helps us keep track of what you're doing. All right. The next thing is let's say you're going to do a I don't know, a box plot. So let's say you're going to do box plot of sample balance. And then you're going to go, yeah, and check what it looks like. Okay, so now you did this. You don't have a heading. You don't have labels anywhere. This is a vertical box plot. When you're doing a vertical box plot, I'm not saying it's wrong. There's nothing wrong with it. But let's say you're doing a histogram and a box plot together in the same window frame. Then it's preferable that you change this to a horizontal profile, because then it will help you read the box plot with the histogram at the same time a little bit better, because then it will give you the right direction. So some people have made a mistake when they had a vertical box plot, that the direction of the skewness was incorrectly red because of the verticalness of the box plot. So when you're reading a vertical box plot, this is your lower values and this is your higher values. So essentially, this should be flipped on the right hand side 90 degrees so that you read it from left to right. So this is from the left side essentially, and this is the right side. This is Q3 and this is Q1. Sorry, Q3 is here, Q1 is here, and this is the median, right? So this is the minimum value, the maximum value, and these are potential outliers. So it's sometimes valuable to rather swap this around and have it as a horizontal box plot so that you can visually see the difference. And it is in terms of the way your eyes and your brain works. And I'm not saying it's specific, it's just like in terms of reading the direction of the skewness, it's easier to visualize when it is horizontal. Not that you can't or that I doubt anybody, you just tend to make less errors when it is horizontal. And so when you need to copy this over, every graphic output, every single one that is important to your explanation or your interpretation or your calculation or whatever, if you've done a box plot and you need to refer to this box plot, you need to copy it and paste it into your report so that I can see what you're referring to. Unfortunately, some people left the graphics out completely. They explained what the graph looked like, but I had no reference. I had nothing to see in terms of what they saw. Because if I run the code, if I run your code, I generally would have less errors. I'm not saying I'm going to have no errors, but I need to see what you saw and what your results were. Because somewhere along the line you could have changed something, not reported that change, and then I have no idea what change was made in the middle of question 1 versus question 2. Okay, so I need to see if this is your output, this is the graph that you're working with. There's a small little camera on the top left here. You're going to click it, and then you're going to go to your Word document. Just want to go to the next page. And then you're going to paste it. So now you see this is a nice big thing. Okay, let me just make this bigger. I now need to crop this. Okay, so I'm going to go to format here. And then I want to crop this. I need to go, do you see my cursor? It's like a little rugby ball at the moment on the side. And when I go on this little black line on the right hand side, it changes its shape. Once it changes to this shape here, it means I can now start cropping, right? So I'm going to make it smaller. I'm going to press crop again, and then I can make it bigger. And when you are changing the size of your graph, always use the corner because it will proportionally increase or decrease the size. Okay, if I do it like this, it's going to change the shape disproportionately. Okay, so I want to keep it like this. Another trick is if you change the shape here in R. No, that's not what I meant. I don't know if you can do this. So here you'll change the shape and it'll be, R will automatically change the shape in a proportional way. Okay, so now you can click, go down here, and then you can, not there, escape, paste. And then this will be a different shape that you have. And now you need to change the formatting. You're going to crop, smaller. There we go, on top. And so now you can see the different shapes of these little thingies. Okay. And then back. Okay. What else did I want to show you in R? Sorry, I'm just looking through my notes here quickly. copy, no screenshots. Okay, if you're going to do a write-out table, right? So you're going to copy this table over. Let's say you want to copy this table over into Excel. I need to see your write-out table function. Okay, write-out table. I didn't name that now, but okay. It's helpful to name it first. And then just this line of code with the clipboard and separate the table with the columns. Then you just have that code as well and copy it over when you're copying over into your appendix. Okay, that was the copy. The Excel. Oh, when you're selecting your sample, right? So you have your population data. Then you're going to select the sample, whatever size sample that is going to be. Don't name your sample the same name that you give your population, because your sample will then overwrite your population data. And you don't know if you're going to need that population data later on in your questions, right? So you name it something different. You have distinct names. Also, if you're going to like, especially in assignment 2 that I noticed it more, is if you're changing one of your variables. Let's say you have a 2-level categorical variable or 3-level categorical variable, whatever it is, and you're changing it to a factor, right? Remember that you need to actually use a different name when you're naming the object. Use a different name for that indicator variable that you're creating. So for example, in assignment 2, I'm going to speak about it again on Thursday, but it's just now on my mind. In assignment 2, for example, when you're changing student, right? Student originally has yes and no, like you see over here. Then you're going to change it to ones and zeros. Yes? Once you've changed it to the ones and zeros, you still need to tell R that this is a factor now, because it is a 2-level categorical variable. So don't name this student, for example, here it is student with a small s, and this you change to student with a capital S, because 10 to 1, you're going to forget if you use a small s or a capital S, and if you use the wrong student, then your modeling is not going to be correct anymore. Okay, so make sure when you change names of something, when you change something into another thing, when you have a population and a sample, make sure that you change the name sufficiently. Don't call it data all the time. If you use data, you're going to get lost in what is data for the population and what is data for your sample. Okay, name it something else. Name it population and sample, so that you know when you're working with the population, this is the data you must use. When you're working with your sample, this is the sample data that you need to use. If you're changing and if you're creating an indicator variable, make sure it's something that looks different to what your original variable looks like. Okay, name that indicator variable something different, so that you are sure you don't make. That's a silly error to make, right? Because it's just going to cause everything else to be incorrect, because now your model is not going to be correct anymore because you didn't change it to a factor, for example. The naming, okay, I said that. Okay. Right, that was that. Then I said I was going to tell you how to create a formula in Word. Okay, so when you need to create a formula or a model, remember the model is the formula. right? It's the same thing. So we're going to go to insert. Okay, so when you go to insert, you're going to go to the right ribbon over here, and there are two options. It says equation and symbol. So you're going to click on equation. Then you're going to have all these options that pop up. Okay, so now you have different structures here on the right hand side, which is quite helpful. Okay, you'll see that this block is highlighted. If you press escape somewhere out of here, then it's not highlighted, right? So if you type anything, it will go down there. So if you want to go back into this, you just type it. Click on it, and then you're going to click on the equation tool here, which is design. Okay, so let's say you now have, let's say you want to use the log, right? So like for your logistic regression, then you're going to go to the right hand side where there's a log here. You're going to click the arrow, and then it's going to give you different options of what you can select when you need to have a log. So let's say this is the option you need to select. You're going to click it, and this is what it shows you in the little box. So now the bottom, the base, we know that that is base E. And now this part here is going to be a fraction, I think. If I'm, okay, let me just go to, here we have logistic regression. Okay, so let's say we're going to try and put this formula, log base E, and then you have this section on the right hand side, which is probability divided by 1 minus pi, and that is in a big bracket. Okay, so I'm going to put this on the left and my word on the right. Okay, so now in here, we now need to have a bracket first. Remember, we're working for the bracket. Okay, I'm going to make it bigger. Okay, in there. So I have my structures. So what do I want now? This is fraction. I first want the brackets because that's the biggest one on the outside. And there's a bracket. So I'm going to click on the arrow. And then I want this bracket over here, which is a round bracket. Okay, so there's my brackets. Now I'm going to click on the inside there. What do I want on the inside of this bracket? I need a fraction. So I'm going to click on the structures, and there it says fraction. What do I want my fraction to look like? I'm going to choose the first one, which is this. Now I'm going to go to the top here. What does my numerator have? My numerator has a P, and then it has a subscript. You see the I is a subscript. So I'm going to go to the structures, and I'm going to look for script. Here I can do a superscript, and this is a subscript, and this has both a superscript and a subscript. For example, what do you use this for? This will be maybe for sigma 1 squared. When you want to, let's say for your hypothesis test, when you want to test the variances are equal or not, then you use the variance of group 1 is equal to the variance of group 2. And variance is sigma squared. So here you'll use sigma squared for group 1 is equal to sigma squared for group 2. Okay. This is when you want to maybe have just written in a different way on the left-hand side and not on the right-hand side. So I'm going to choose, no, not this one. I'm going to choose a subscript. Okay, so now I did both, but now I don't want this on the left. So I delete that one. Okay, so now I have a subscript. So here I'm going to type on my keyboard a P, and then I'm going to click in the small little bracket, and that needs to be an I. So I'm going to click it on my keyboard. Okay, then I'm going to go to the denominator. And my denominator, I want 1 minus pi. So here I'm going to type on my keyboard 1 minus, and now I need P subscript I. So I'm going to go to my structures. I'm going to go to the script, and I want the subscript. So yeah, I'm going to click in that small little box. On my keyboard is a P, and then that small little block on my keyboard is an I. Okay. So there we have the left-hand side. So now I'm going to say is equal to, and now I need something on the right-hand side, which is whatever it's going to be. Let's say I'm going to copy this part over here, beta 0. So again, I'm going to go to, let's say it's equal to, and then I'm going to go to design, structures. I want another subscript. Yeah, I want the symbol now in there, which is beta. So now I'm going to go to the symbol section. I'm going to go to the down arrow, and I'm going to look for beta, which is there. And then my subscript is 0. I'm just going to type 0 in on my keyboard. And then to the right, I'm going to say plus, and then I need a structure, which is that one, which is B1, and then I need another subscript next to it. So yeah, I need beta. This is going to be a 1, and then this is going to be an X, and this is going to be a 1, comma, I. Okay, and then you can continue with whatever else you need. Let's say you need, I don't know, plus I don't know what else is fun to use here. An accent. Let's say this one, if you have a P over there, you can do, what else is fun here to use? You have different kinds of brackets. If you need a square bracket, a curly bracket, you know how to use a round bracket. There's also, I think there's long brackets as well. If you're using, what's the word now? A combination in probabilities, then this is the bracket you'll use for that. Combination 6, 2, for example, whatever the case is. So this is a helpful tool when you need to write down your model or a formula or something like that in Word. And when you transform your, if you, change your document into PDF, it will copy perfectly. Okay. Okay. I think, oh, that is all the, where is my assignment? Okay. So, assignment. Everybody did quite fine here for your question 1. Deciding whether it is categorical or nominal or numerical, sorry. And then the explanation is just a matter of being a little bit more specific, like saying the reason should not be it is categorical with 2 levels, for example. If you're saying it is categorical and nominal, for example, default, you have to say what characteristics of default makes it nominal. Okay, so yes, the fact that it's got 2 levels, the fact that it is non-numeric, and then you have to say like there's no ranking or ordering in this variable, right? It is a success or a failure, and that is it. And that is what makes it nominal. If it is continuous, for example, you can't say it is continuous because it's continuous for balance or income. You have to actually say that the values are in a range, it can take on any value in a range of values, including decimals or fractions. That's what makes it continuous. Okay, so be specific in that. When I ask you to copy and paste this table over into your Word document, actually do that, because when we're marking, we're going to mark according to this table. So swapping this over here, numerical or categorical, or nominal and ordinal, I'm not going to look at the heading. Just going to look where you placed your X so that I can see, okay, that is what it, because I expect you to copy and paste this table over exactly as it is. Okay, same goes for this one here. I expect you to have a class because this is the table that I'm giving you to copy and paste over into your report. So this is what I want to see in this order. Nothing more, nothing less. Okay, I expect it to be like that. This is the order that I want it in. And that is why we give it to you. That is why it's not an open question. I didn't stop there. I gave you this table so that you can have this structure. The only thing that you have to now do is get the correct amount of intervals, which is also, okay, we'll get to that step now. Okay, so that is one of what I wanted to see in this explanation over here. Okay, 1.2, fine, everybody got it right. Maybe one or two selected a different variable there, but majority got that right. And then perform initial descriptive analysis for your categorical variables. Okay, present them using visual aids and interpret them individually. So the choice of words in this question are very important. Okay, initial descriptive analysis. So that tells you you get your data. What is the first thing that you need to understand? And this is every time you get data, whether it is simulated data, real data, clean data, raw data, doesn't matter. The first thing that you need to do is perform a univariate analysis. Univariate means you're going to take each variable in your Excel sheet and you're going to do some initial understanding of what that variable looks like. The purpose of doing that is to see, is there any skewness? Is there any values that are missing? Um, is it going to have a linear shape? Is it are there any outliers that we need to be worried about? What is the shape of this distribution? What does the averages look like? For categorical data, you're not going to calculate an average, but maybe a median, stuff like that. Okay, so we need to first understand what does this variable on its own, without looking at anything else, without comparing it to anything else, what does it look like individually? Okay, so that is very important. So a lot of you guys wanted to be, a little bit extra and compare the two, and by 1.3, 1.4, and this versus that, and whatever. That's not the idea. Like, we will get to that part when it's that the time to get to that part. But when we want to do initial descriptive analysis, we want to first explore what the data looks like and what it's telling you, because that is going to give you a picture of how your variables look if everything else was not there. Okay, so you need to first understand what it looks like in isolation before you can start understanding the interaction between the two, or the three, or the four, or however many variables you have. Okay, so when we also, some of you do the visual aids and then you forget to do the interpretation. Okay, so You need to read the question properly so that you can answer each part of it, so that you don't lose marks unnecessarily. And if you're not comfortable with your interpretations, then you're going to have to practice it before the exam, so that you are comfortable with it. And even if you don't explain absolutely everything, explaining something is better than explaining nothing. Also, don't you see? So, for your categorical variables, you've identified two categorical variables in 1.1, which is default and student. So now you have two variables. If I ask you to explain them individually, it means that this 6 marks have been divided between the two variables. So 3 marks are going to be for default and 3 marks are going to be for student. Okay, don't give me a 1 page explanation on default. You're going to get 3 marks for wasting so much time and space in your report. Firstly, it's an exam. Just remember, look, the assignment is done, right? You can't change anything that you did in the assignment. This is just to help you prepare for the exam. You have a time limit for the exam. You only have 8 hours, right? So you can't spend all that time explaining everything. Adjust your level of explaining according to the amount of marks it is for that question. You don't have to write a full paragraph for 1.2 if there's only 2 marks. Does that make sense? I need you to tell me the most important information, but you have to tell it to me in a precise and concise way so that you're going to get those 2 marks and explain it in a short amount of space. Okay, here, for example, for 1.4, there's 2 numerical variables and there's 8 marks. So this 8 marks is going to be divided by 2. 4 marks for balance and 4 marks for income. Here it says perform numerical and graphical descriptive analysis for the numerical variables. So here, numerical descriptive analysis is going to be what are in your descriptive analysis section, right? What did we go over? Also, it gives you a hint because we want you to go through central location, dispersion variability, and the distribution shape. So for your central location, if you like a few of you have done, you separated your descriptive analysis in those 3 sections. Your central location is going to be mean, median, mode, right? Dispersion variability, that's going to be your variance, standard deviation, your quantiles, your interquartile range, your coefficient of variation, etc. Your distribution shape, in terms of numerics, that will be your skewness or your kurtosis, right? We didn't really touch much on kurtosis, but skewness definitely, and we did the formula for that as well. But that, if you want to comment on the kurtosis, you can Google how to do that. That's no problem. Okay. Your graphical descriptive analysis here, in terms of numerics, you have different options. There are many options in terms of graphical displays. You have categorical variables. Here it says present them using visual aids. So the difference is, for visual aids, it could be tables or graphs, right? So either of the two were marked, or both. And then here, graphical description is now something else. So here we want a graph, right? So you can choose between, do you want to do a histogram, a frequency polygon, an ogive, a box plot, whatever the case is. You have different options there and you can choose which one you want to. For this one, for the graphical displays, if you choose to do a graph, categorical variables are usually a bar graph or a pie chart. Those are generally the options. And then if you want to do a little table showing the proportions, then that is was also marked, and that is also fine. With your numerical here, with your categorical variables, also remember you can't calculate an average, right? You can calculate a mode, right? You can say, okay, this is the category that has got the highest, if you have more than two categories at least, this is the category that has the highest frequency. But you're not necessarily going to calculate an average, right? And so you're going to report that. You need to, instead of, in terms of writing it up in your report, you have graphs here. I didn't do a table, but this could be converted. This little sentence could be converted into a table. And I marked those that have made tables. So this is what I was talking about when I was saying having a horizontal box plot. When you have a histogram and a box plot together, you can see the shape of your histogram with the shape of your box plot together, right? And then it makes a little bit more sense than having this in a vertical way. It just helps to read the table, to read your graphics a little bit better. And then when you have, so this is just the ones that I've written down, but there could be more. Having it in a little table like this, it's just a way of presenting your findings in a, I don't want to use the word nice, in a visually appealing way, if I can say it like that. So you have the name of the variable, you have the different descriptive statistics that you've calculated, and these are all the values. Okay, instead of just writing it out in different lines, having it precise like this, it's easy to see, it's easier to understand, and so it makes a little bit more sense. When we want you to interpret, we want you need to make full sentences in your interpretation. No hyphenated words or what's it, abbreviations. You're not writing down keywords here. In your interpretation, you need to make full thought out sentences in a statistical manner, right? So a lot of you did that very well. The only thing that I would say for those that have gotten good marks in this section is that I used rand here. I know it wasn't formally stated whether it was rand or dollars, whatever it could have been, whatever. But select one and then say it's going to be in rands, and then I need to understand, or I need to know that you understand that this information that you're dealing with here, all these values are not just amounts. These amounts are related to a currency. It's got to do with money, right? And so interpreting it in that way is important. I need to know that you understand these values are related to money. And if you leave your interpretation with no currency whatsoever, then it tells me that you're not fully understanding how to interpret these values. Okay. And so there's no perfect way to write this out because you can choose any of this information. What I need to see is, are you relating to the question itself? So I want to individually, so you'll see here in my answer, I separated it. This is balance, all the information related to balance. Then I have income, and this is all the information related to income. I don't want to see your two histograms next to each other. I don't want to see balance and income next to each other. I don't want to see the box plots next to each other because that is what's convenient for you when you are doing your code. That's not what I want to see. I need to see it, everything, because that is what the question asked. I want to see them individually. Okay? It's not about comparing the two, it's about understanding what is happening in each variable separately, as if it was in isolation. Okay, so are you answering the actual question? Have you referred to your in your interpretation to central location? That means main median mode. Have you spoken about the variance or variability? And have you spoken about the distribution shape? Though that is how we're going to mark the question. If you've spoken about all of that correctly with the right rand or dollar, whatever, excuse me, then you'll get all your marks. And like I said, you can use whatever graph you want. You could have used a frequency polygon. You could have used a ogive if you want to. You can use whatever. The one thing that I don't want to see here is a frequency distribution because that is not giving me numerical descriptive statistics. A frequency distribution is what is used to create this histogram, right? But that is not what numerical descriptive statistics is. This is numerical descriptive statistics. These things, in a minimum, these are the ones that are important. Okay, same thing for income over here. Okay, so question 2, let me just go to the questions quickly. Does anybody have any questions before I go to question 2? Can you do a set.seed function, copy data from R into Excel? Okay. What is this? No, don't. I just close that. So I just want to close this window. Save. Okay. Any other questions before I go to question 2?
Yes, Ms. Mokel. From me, I just need to know, will you get penalized if you, for instance, I think I added too many intervals for my histogram. And then also, I think I created density curve on the histogram. So will we get penalized for adding those things, although the histogram is more or less correct?
There is correct and then there is wrong. Some histograms could be correct and others could be very wrong. The idea is for you to use or to generate the most appropriate histogram for you. Okay, so I taught you the steps and how in the background the intervals are selected, right? But in terms of actually selecting it yourself, you have the code, which is much quicker and much simpler to use, and it's going to be more correct because R will then take into account everything that it needs to take into account before it gives you the correct amount of intervals for your data. And yes, there is a wrong histogram that you could have because you might not have the right shape in your distribution. When you have too many intervals, then it's going to be the interpretation will be different. If you have too few intervals, the interpretation is going to be different. And so there needs to be some sort of like a range in which there'll be the correct amount of intervals to a certain point. I don't know if that makes sense to you, but
No, understood. However, just remember that I don't use just the one program for doing my R coding. I do use other tools as well. So you understand? So sometimes,
What other tools?
well, there's Colab, which is a Google one, which is you can do it via the web. So sometimes I make use of that because I'm on a Mac, so it's extremely difficult for me to get the everything working 100%, especially like it's not similar to the Windows environment. So I do make use of different various other tools as well, just to do my coding.
Therein lies the problem is that I can't code for everything or all the possibilities out there. That's why, like I said right in the beginning, this is the one that we chose so that everything is going to be uniform for everybody. So that's going to be an issue if you're not going to have the same. If you're not going to use R, then how do I check it?
No, understood. So I'll make sure
So
that,
that's
yeah,
that's the problem.
no problem.
I don't know how you're gonna work around that though, because there is R for Mac, isn't there?
Yes, there is R for Mac, but it's not exactly 100% the same. It's slightly different as to if I do follow instructions and things like that, especially if I do YouTube videos on Windows R, it's not the same as Mac.
And there aren't any Mac videos.
They, yeah, it's very difficult if you want to, if you're looking for something specific.
Mm-hmm.
You don't always get the videos for Mac.
It is challenging. I can agree with that.
Mm-hmm.
Even some basic functions that you would do on Windows are very different on a Mac. Yeah.
Mm-hmm. God, I hate Apple. It makes it so challenging. Everything is so much more challenging unnecessarily. Um, it's so yeah. I don't know what the workaround for that is, unfortunately. Um, I don't know. I don't know how to troubleshoot that one.
No, I'll try my best to use a Mac version, when I do the
Yeah,
coding and things like that. But yeah,
yeah. Look, the thing is that once you start opening up and using different platforms, then what is stopping everybody else from using all different kinds of platforms? Um, and then I have no control over that. And some people are more comfortable using Python, for example, and some people are more comfortable using Excel and all of that. And I can't, I won't be able to manage all of that differences. So yeah, this is, yeah, I'm not exactly sure. Okay, talk about, um, oh, yeah, selecting the intervals. For example, this, we're jumping now a little bit to the next question, but for example, yeah, after you've selected your sample, and some people have selected their own size of the interval, right? So this was these tables or these intervals were automatically selected by R just using the hist function, right? Um, and so I assumed that everybody was going to use that hist function, but many people actually used actual calculations, going through 17 steps in order to get to what the right amount of intervals were and what the sizes of the intervals were going to be. Um, and then ending up with too few intervals or too many intervals. R also automatically creates an interval that is going to be easy to understand, right? Some people also made an error by when creating their own intervals, for example, stopped at 4,999 and then went over to 5,000 in the next interval, and then stopped at 9,999 and then started at 10,000 again in the next interval. So, which is absolutely wrong, because when you have continuous data, there's so many numbers between 9,999 and 10,000, right? Especially when you're dealing with money, because then there's decimals involved. And with continuous data, your numbers are supposed to continue. And so you must make sure that you use the correct brackets also when you are reporting your intervals, right? So you must make sure what your square bracket means and what your round bracket means, which one is inclusive and which one is exclusive. So in this instance, I have 5,000 is not included in the first interval, but it's included in the second interval. And so the square bracket is including 5,000, and the round bracket is excluding 10,000, because 10,000 would be included in the next interval. So just make sure that you understand what the difference is between a square bracket and a round bracket and use it appropriately. If you have the upper limit, for example, and you want to include 10,000 in the second interval, for example, then you would have the square bracket on the right and the round bracket on the left. So whatever one you choose, just make sure it's chosen correctly according to your frequencies and how it was calculated. Okay. Okay, so I made a little note on that, so I'll just take it off. Yeah. I'm not sure if I opened my code. I had my assignment open. What did I do? Oh, my code is at the bottom. I wonder if I should just open the code separately. Okay. Dale, you asked about a set.seed. Where did we do a set.seed? In number 2, I think. If you do a summary, if the question asks for summary statistics would be this one here, which is the minimum, first quartile, median, mean, third quartile, and maximum value. And then others would be descriptive statistics. And these are some things that we'll have to do separately. Okay, intervals. In order to calculate these intervals, I just simply used the hist function, and then I got these intervals, and those are the ones that I used for my frequency distribution. So here's the set.seed sample. Did I not do a write.csv? Yeah. Here's this.
Sorry, Chanel.
Yes.
It's actually, yeah, I think it's a write.seed where you copy the, like where you split the data into your sample, then you copy that sample over into Excel and save it. Is that the write.seed function?
No. What the set.seed is just choosing a sample from your population that you can replicate, right? So this is selecting the sample and the size, and there you guys use different. Some of you used a ceiling, and some of you used a floor function to 20%, as long as it was a 20%, that was all fine. And then I checked that it was correct. I wanted to see that there were 2,000 rows and 5 columns, and then I saved it. Right, so this part here is how to save it to Excel.
Yes. Yeah. Sorry. Right. Yeah. CSV. Because I struggle with that, but then I googled and I managed to get like the clipper function, so that worked.
But how
Because when
come
I
this
tried it
didn't?
out, I'm not sure. Yeah. Because when I tried it, then it copied like half of my data, but then with the clipper function, it actually worked. But I'll try that when I do now prep.
Okay, but I mean, if your clipper function works, then it's fine. And you can
Okay.
just have that code there, so that I can see it, and then I can
Okay. Gotcha.
check with my sample as well if it works. And yeah, the point is not for you to. The point is the point of this is, let's say you make a mistake at question number 2, right? And for whatever I don't know what happens, and you can't get, things are not just working out. You want to reload a sample, you reload the sample from where you saved it. You don't have to resample again. You just have to, um, like I did here right in the beginning, you're going to read it in from your wherever you saved it. Does that make sense? So don't send it to
Gotcha.
me. I don't need to see what your sample looks like. I just need to know when you do your sample, this is essentially this part is what I want to see. All of the stuff. I want to see you did a set.c like I told you, so that your actual data, your student number should be here. I just chose 2025. Your student number should be here. Um, you selected the correct sample, and then I want you to check, do this, a dumb sample and a head sample, so that you can see this is the number of rows that you have, this is the number of columns that you have in your actual sample. So then you know you selected the right size sample. Yes. And then a head sample will just be to check the first 5 or 6 rows. What does it look like? And if you have all the information in this 5 or 6 rows, that's all you need to see. That's all I need to see, so that I can check, okay, you did it correctly. And then you save your work. This is just a matter of saving your work. Okay, so when you select your sample, this is what I need to see, and you'll get marks for all of this. Okay. Alrighty. We skipped.
Chanel,
Yeah.
just one last question. Like when you save in R, right? If you navigate to R and you save, because I had some issues with saving in R. Like I saved and then I went back and then the data was gone basically. And when I tried to like re-import the data, that also didn't work. So do you just click on that button save
So you
and
click on it,
you
and then you're
name
gonna
it
go
like
to,
assignment 1
yes,
or exam, etc. And you save, and that's how you save in R.
yeah. So okay, let me just go here quickly to 013 assignments. I don't know, assignment. Okay, so I have 2 already. I'll just do assignment 3 underscore 2025. Let's go up quickly. The assignments. This one I can't even spell. 3 underscore and save. And then you should get a something like that says you saved the image,
Yes.
right? And then you're gonna go to wherever you saved it. Not there. Assignments, and then yeah. So you'll have assignment 3.
Okay, so if you click into that, Chanel, does it open up or does it open into the R console?
So now you have to go here. I'm just going to click stop here because I wrote a stupid line there. And then you're going to open. And then you're going to go to 713 assignments, all files, assignment 3. And then it should give you whatever you have. But okay, I don't have anything really saved there. Let's see if I can just open something else.
So if you type in sample head, will that information then?
I can't now show you what my exam file looks like, but okay.
Okay.
So let's see what I have in the I have my sample. What else? Maybe let me see what model I have in here. Model 3. Okay, so this was one of the models that I made for assignment 2, for example. Income balance student, yeah. Model 4. There I have income and balance without student. What else? I don't know, but that's essentially how it's supposed to work. You're supposed to go to open a script that you've been working, or you can load a workspace. Let's try if load a workspace is going to be better. Assignments. You maybe try that because there it said load, and then it had both assignments there. So you click on load assignment. Okay.
Okay, thank you, Chanel.
So this is OpenScript, and this is load workspace. So I think, yeah, when you save the workspace, afterwards you close down and reboot, then you can maybe have a try that one and see if it works. And if it doesn't, then you must just try and figure that out before your exam. Okay. Okay. Right, let's just get cracking. Okay, so question 2 was the set.seed. Nobody had problems with that. Everybody did that correctly. Everybody saved the right size sample. If some people used, like I said, a ceiling function, some used a floor function, some used a normal function like I taught you. There was different functions that lots of you used, which was absolutely fine because it was all correct. And then we did a cross classification. The thing that I wanted to mention here was make sure when you do a cross classification, you copy it over into a table so that it makes sense. Make sure that you always add your totals. There is code for your totals as well. Margin 1 gives you the rows, margin 2 gives you the columns, and then you have the appropriate headings. Please make sure that you don't swap this around. Copy the table over exactly as it is in the output that you get, because yeah, it is. I mean, you're not going to make it more fancy by making the table inverse or the wrong way around. So generally what I want is when we say student by default, we want student in the rows and default in the columns. But if you do it the opposite way around, it's fine as long as your numbers reflect that. It still makes sense. So here by 2.2.4, we wanted the percentages, and you have code if you got If you change the entire table into percentages, then you got all 3 marks. If you did it manually, calculating 28 divided by 2000 multiplied by 100, you got less marks because that's not what we wanted to see. We wanted to see you use the table. Yes, does somebody have a hand? Go ahead.
Oh, yeah, sorry, ma'am. Sorry if I'm like going back now, but I was just with the samples. So I realized like I actually didn't save my sample to an external SCSV file. So I wanted to know if that will be a problem when marking assignment 2 because I actually have to reuse the sample from assignment 1.
Didn't you use the same sample?
Yeah, it is the same sample, but I'm saying in sample 1, like I didn't save it on like a CSV file.
But it's the same sample.
Yeah, still the same sample, like nothing changed, but just that in assignment 1, because I'm looking at what you did where you actually save like the sample as a CSV file.
I'm
So
not
would it,
understanding the question. Like you use the same sample in question in assignment 2.
yes, but I'm wondering, is it like a problem because I didn't
What's
save it?
is the problem now?
Like for you, is it going to be a problem for you?
I'm not understanding. Is it the problem?
So can you please just go to like your code for question 2.1? So for example, yeah, like save the sample, right?
Yes.
.csv where you
Yeah.
save it. So I didn't save like the sample to a CSV file.
Okay. But you got
But
assignment 1 marked already.
sorry?
Did you get your did I returned your script, right?
Yes, it's everything you marked correctly. So I was wondering like if that is gonna like pose a challenge for you when marking assignment 2.
No,
Okay.
because you use the same sample.
Oh, okay. So it
No,
doesn't really
this
matter.
is for this write.csv is for assignment 1.
Yes.
When you get to assignment 2, all you need to do is load your sample into R.
Okay.
That's all.
Okay.
Where you saved it, I don't know. You got marks for it in assignment 1, or you didn't get marks for it in assignment 1. So it doesn't matter to me in assignment 2 as long as it's the same sample.
Okay. Thank you.
Because in assignment 2, I don't ask you to save a sample because
Yeah, I understand.
you already saved it. So
Okay. Thank you, ma'am.
okay. Okay, so I told you about the frequency table over here, what we wanted. And so this 10 marks were because I wanted to see all the code for calculating, getting your frequency. Your frequency would have you would have gotten as the count. I can just show you quickly. Number 3. Here for the counts, this will be the frequency. And then to calculate your relative frequency, cumulative frequency, relative cumulative frequency, 5 marks for income, and then 5 marks for balance. Okay? And if you didn't get all of those marks, it's because you didn't have the code to do these calculations. So I assumed you did it in Excel. And so you didn't get the marks for that. Okay. Question 3.2. Here we want a relative frequency percentage histogram. And I feel like a good portion of you didn't see the percentage part. And so you only had the relative frequency here and not the percentage, which is what we wanted. So essentially, it's this column here, this column that we want you to get a hold of and have this on the vertical axis, right? For both of them. And so the code for that is just to use the histogram function. And in order for you to get that, you need the lattice package. if you're using one of the older R's. If you're using something else, some students used I can't think now what. Sorry, it just escapes my mind. But then if you used, this is for example, the output for using this function, right? The hist function. And some of the output here is density. And this density is not what we wanted as the vertical axis, right? I did not want the density function. I wanted the relative frequency percentage, which is these ones over here, to be on your vertical axis, okay? And then creating a histogram for that, for both income and balance. And then the only thing that you need to add in here, which you don't add in when you do your normal hist function, is to highlight how many breaks you need. So this highlights the number of breaks in terms of the actual histogram that you created, not the histogram, the frequency distribution table that you created, the amount of intervals you had there, it correlates to that one. So now you can change your, no, I don't want to go back here, sorry. I want to go to this one. Your horizontal axis, you can change to the actual intervals here. That is fine as well. Remember also, if we ask you to copy and paste your graphs, you need to copy and paste over into your Word document and then interpret your results. So many of you did the copy and paste and forgot to interpret. Even a short little sentence would have been fine. When you don't have the correct number of intervals, generally those that didn't have the correct number of intervals did not see this bimodal shape that we have here. And that is essentially the main problem with not having the right amount of intervals. If you have too few intervals, then you see a bell shape. And when you have too many intervals, then it's multimodal. And this creates what is actually underlying this distribution with a correct or appropriate number of intervals. It shows you that it's bimodal and it's skewed to the right. If a distribution is bimodal, then it cannot be symmetrical. Okay? Because a symmetrical distribution is bell-shaped and it is leading you to believe that there is some normalcy in that distribution. And when you have something that is bimodal, meaning you have two peaks, it cannot be a normal distribution any longer. Okay, this one is skewed to the right. It is also not normal. Okay, having this shape, if you had a box plot here instead, then it's more difficult to see if a distribution is bimodal. You will see the skewness in a box plot, yes. You will see outliers in a box plot, yes. But in terms of the shape of the distribution, when there is more than one mode, you won't be able to see this with a box plot alone. So for example, here in question number 1, if you had only a box plot with no histogram, then essentially this is what you are interpreting. And from this alone, you cannot see that it is bimodal. From this information here alone, you also cannot see that it's bimodal. The only thing that's going to give you a clue is that when you're trying to calculate the mode, there is none. And when you see something like that, then it's beneficial to investigate a little bit further to try to understand why has no mode been found. Okay, and sometimes it's not that it's bimodal. Sometimes there just generally is no mode, and this happens more often when you have continuous data that has got decimals in it. And if your data has got decimals in it, then it's very difficult to find a mode, because remember your mode is that observation which occurs most frequently. So that makes it a little bit difficult. But the useful thing about having a histogram is that you can see with numerical data, continuous data, what the actual shape of the distribution is when you have the appropriate number of intervals. Okay. For example, here, some people had the incorrect number of intervals, and so the very first interval was very, very tall. Like this was a very, very, very high number, the first interval. And then the rest looked similar to the shape. And so now you have to ask yourself, does that create it, that distorts the actual picture of what your distribution looks like? Okay. So having the correct number of intervals, or the more appropriate number of intervals. For example, if you have 14 intervals instead of 15, then there's not such a big train smash. But if you have 20 intervals and you're only supposed to have 13, then it makes a big difference. If you have 5 intervals and there's supposed to be 15 intervals, for example, and then that makes a big difference in what the shape of your distribution is going to be. Okay. Yeah, deciding on having 10 intervals also, just because it's a round number. If there's no reason why you have chosen 10 or 20, then it's not doesn't make statistical sense to do so. Okay. Okay, so here you'll see the same pattern that was that would exist in your frequency distribution in your histogram, because it comes from the same data, right? So the shape would be similar, but the sort of test here was, can you now change what this histogram looks like by changing the vertical axis? Okay, that was essentially what we wanted to see. And then your ogives. Did I write something about an ogive? Yeah, I feel like I did. Oh, so yeah, with your ogives, what we wanted to see is there is a difference. I mean, visually, an ogive helps you to understand where data lies cumulatively. That's the word I'm looking for, right? So an ogive is a visual representation of adding the data cumulatively in a sequential order. So one after the other, after you have ordered your data from smallest to biggest, right? How do they add and stack on top of each other? And you'll see that these two variables give you different shapes, right? For income, there's a lot of data in the lower end, and then because this is very straight at the bottom, and then it sort of increases, and then it steadies off, and then it levels off towards the end, which is different here to what the balance looks like. There's a steep incline right from the start, and then it levels off earlier than what the income does, right? And then there's a long leveling off in the last part of the data. Now, in terms of percentage-wise, how does that differ? Okay, so like 20% is 20% of income will be somewhere around here, right? Which is much later in terms of intervals than what your balance is doing. Okay, so what are the intention of doing this is for you to be able to see, you get a picture from the ogive visually, and how does it compare to doing the actual calculation? Are you understanding the information that the ogive is giving you in terms of a visual mechanism to use versus what actually you can calculate in R? Because this helps you to see the differences in terms of interpreting what your graph is showing you. Okay, so that is what I wanted you to be able to see. Yes, you can do the calculation. You can write the code in R, and there's absolutely nothing wrong with that. But actually, what is the visual output? your graph. What is it telling you? And can you interpret what the graph is telling you? Okay, that's what I wanted to see. For the most part, people got this, answered this question very nicely. There were some that didn't really, I don't think, grasped what I was asking for. But for the most part, this was answered quite fine. So I don't have any issues where this is concerned. This one here, 3.3.5, I think the errors that were made here were mainly that you didn't know that you were supposed to do both the approximated IQR and the calculated IQR, and then just see what was the actual difference between the two. So that was it. I'm not sure if I didn't. Yes.
Okay, good evening, ma'am. So when it comes to this question, when it comes to the decimal places, we shouldn't, because you mentioned on the feedback, you shouldn't round up. We should
No.
leave it as it is, like two
Yeah.
decimals at least.
Yes. Why do I say two decimals? Because if you're dealing with currency, whether it is rand or dollars or euros, whatever it is, we normally have two decimal places, right? Yes? That was a question?
Yes, ma'am.
Yes, you have two decimal places. So that is why you round off to two decimal places, because again, you're interpreting the values as currency. Okay. Yes, you do not round off because you're not supposed to round off. These ones here are approximated. So I don't expect you to have any decimals here, because I wouldn't expect anyone to say, from this graph, it looks like it's 21,495 and 35 cents. Okay, there's no way that you can see that number, including decimals, from this graph alone, unless you use code to do it, unless you're going to actually calculate something. So no, here, when you need to approximate, you're just going to read off the graph and give an approximate number. And so I rounded that off to a whole number, because it's just giving me an idea of where it is placed. But when you do your actual code, you're going to get a number that maybe has 4 decimals. Because you're dealing with currency, you're going to round off to an appropriate number of decimals. No, don't round off to a whole number, because there's nothing wrong with decimals. Okay, for example, everybody's marks, if you did your own calculation for your assignment, you would have noticed that I rounded up for your percentage. So let's say you got 71 out of 145, and it was actually 65.2. I rounded it up to 65.66. I know that is not the correct answer. I'm just giving an example. I rounded it up to 56% or 66%, whatever the case is. But in actual fact, let's, for example, say if you rounded this to a whole number, this would be 21,015, right? Because 19 is rounded down. Okay, so no, don't round off unless it's asked for you to round off. And then here it says use box plot and numerical summary measures to comment on the shape of income and that. So box plot, horizontal. I prefer using horizontal because it's helpful in terms of this deciding the shape of your distribution. And summary measures, it means summary statistics. So this is going to be your minimum, Q1, median, mean, this one's. And if you check the code, it is 3.2, 3.3 quantiles. Yeah, so this is going to be a summary. This is actually the code that you need to use. You need to use the summary code, the summary statistics for that. That too, that is what we mean. That is what summary measures means, numerical summary measures. That is what it is, because essentially these are all points on these graphs, right? This is a 5-point summary. So for income, this is this number here is going to be 2,541. This number here is 21,015. This number here is 33,950. This number here is 43,829. And this number is 72,461. Okay, so it actually, that is why I asked for this one, is because then we can relate it exactly to what is happening on this box and whisker. So the issues that I saw here was just that some people didn't do this, some people used different summary measures. Here you actually calculated descriptive statistics, which is not what the question asked for. And then you didn't get the marks because this is what we wanted to see, the summary and the actual box plot, because that is what is given in the box plot over there. The code for question 4, splitting data. So yeah, I just showed two different things. The first one is if you just take your one variable and you split it and then work with that. And then the second option here is if you split the whole sample. The question did ask for splitting the whole sample, but it wasn't completely wrong if you did it like this, because we only wanted you to work with the default versus no default in any case. The income thereof. So these are the two options that you have. Some people, majority of the people did this correctly. There were a few that didn't do this properly, or didn't save it properly or something, or didn't translate very well into the calculations further on in the question. But I'm just checking if I had a note on this quickly. Okay, I did that. Yeah, but did anybody have any questions about splitting the data? Did anybody have issues that you want me to go through? No? Okay. So yeah, again, I said you can do a subset, or you can do a sample split. So yeah, I did samples, and here I did the subset, and yeah, I did the sample. So there are two methods. Let me just see if I can. Okay, so I think this is on the on your Canva.
I think it is, yes.
Okay, so yeah, both methods work. It works fine. It's just which one you're comfortable with using. So yeah. Okay, so that is there as well. Close that. Okay. And then doing this for each sample group, construct a histogram and a QQ plot, and then comment on the approximate normality. So the group of defaulters are smaller than the group of non-defaulters, right? So your sample, splitting it, there are definitely less in your defaulters than there are in your non-defaulters, and you can see visually just how many dots there are here in the QQ plot versus the defaulters, right? That just shows me that they're much less in this sample there. And also your intervals here for your histogram, you can see that they are different as well. And that is just because your sample sizes are different for your defaulters versus your non-defaulters. Okay, so here you can see that this is bimodal. And if it is bimodal, it cannot be normal. Okay, and then you can see when it makes an S, right? And even though this is not a very, very big or hard S shape, but there's lots of deviation here in the tails. Okay, and if you look at this, there's only a small section here that is actually on the line. This is not on the line. This is not on the line. This part is deviating. So when you have the shape of the histogram, and that is why it's always useful to have the histogram, is to see if there is a bimodal section, right? And that helps you decide. Actually, yes, this is deviation enough for it to be not normal. And so this is something that maybe next week after, because Thursday we're doing assignment 2, next week we can go over some revision, and then we can go through some histograms and QQ plots to see when we are interpreting them, how do we interpret them? How do we know that we're making the right decision? Because it is subjective in terms of how you look at it and what it all means. So then we'll go over a few of that as well. Okay. Again, here, this is bimodal. There's two modes. It goes up and down and up and down. So this is definitely bimodal and skewed to the right. So here it's more obvious, this S shape over here, that these tails are definitely deviating. There is a small section in the middle that is looking like it's on the line, but it's definitely not normal because of this histogram that's also giving a bimodal shape. Okay, so for your tests, when you're performing an hypothesis test, how do you know you're performing an hypothesis test? If the word says test at the 5% level of significance, it means perform an hypothesis test. Okay? Show all steps tells me I want to see the hypothesis, the null hypothesis, the alternative hypothesis, and I don't want you to write it out in words. I want you to use statistical notation. It is important because this is a statistical course. So I want to be able to see, you know, what the statistical notation looks like, what kind of test you ran. So what does this look like? And then how do you interpret the results? Do you have all the information that is necessary when you are writing this? No, this is not necessarily. For example, you don't really need to write alternative two-sided. Yes, you do need what the confidence level is because this could be different. And yes, you do need to write that it is not paid. Okay, so that is important information to have. And then some people chose to use a broken down F test, for example, calculated the critical value, calculated a confidence interval, calculated the test statistic, calculated, the fraction for what F is equal to MSE divided by MST divided by MSE. And so all the calculations, fine, all good. If you got to the right conclusion, that's fine. But if you're unsure of those steps and you took 20 minutes to complete just this one section, I feel like that is wasting time. Okay, there is an actual test that we perform, which is an F test. You have the code for it in your slides. Use it to your advantage, right? Like I said, when you're writing your exam, you are working against the clock. So save time when you can save time if there is a shorter code that you can write instead of having 12 different steps that you need to perform in order for you to get to a conclusion, right? Practice it, make sure you understand it, make sure you know when to use it, when it's appropriate to use, what information is necessary, and then how to interpret your output, right? So here we are interested in. So some people had calculated the F statistic separately. Some people calculated the confidence interval separately, and then the ratio of the variances, which is your critical value, separately. And so that's all well and good when you can just do a VADA test and you'll get all of that information after you click enter. So you write down this code, you click enter, and then this will come up automatically for you. And I think that is saving time when you are in a test situation and you need to save on the time that you need in other places, right? In terms of writing up and explaining what these values mean. And then you highlight in your code what is the thing that you're looking for that's important. And so I highlighted this p value, and that is the information that I need to transfer over into my explanation, which makes up this 5 marks, right? So in your conclusion, you need to write full, complete sentences. You're not going to write H naught in your explanation. H naught is left for your hypothesis. It's fine to write H naught and H1 there, or HA. This is your null hypothesis, this is your alternative hypothesis. But when you're writing out an explanation, you need to write it out in full, complete sentences. Capital letters, commas, full stops, all the grammar that's important when you are writing sentences. Okay. Then you can decide on what you want to write. However, don't use the whole page in order to write one. I mean, you're going to waste space. Okay, so you need to be, I think some practice is going to be needed for you to write out what is important and what is not important. So what is important when you're writing down a conclusion in an hypothesis test? You must have your null and alternative hypothesis there. Okay, you can explain what test you performed. Then you have to report what your p-value is. Then you have to explain what you're going to do with that p-value. When you compare that p-value to your significance level, remember, the significance level might change depending on what is given to you in the question. If nothing is given, you assume it's a 5% significance level. You compare it to that 5% significance level, and then you need to say, are you going to reject the null hypothesis, or are you going to not reject the null hypothesis? You actually have to say that. And then you must explain what does that actually mean in terms of your test and in terms of your data. Okay, it's not a generic answer. Your answer needs to be related to what your hypothesis is here, because you can't tell me I need to reject the null hypothesis and you don't have this information here. I cannot assume that you know what the null and alternative hypothesis is. Okay, and again, this is not full sentences. This is statistical notation. Then you can say, okay, this is what we are understanding to be the outcome of my statistical test that I'm performing. Okay, and those are the important pieces of information. Now you can write in 5 different sentences. That's fine. You're not writing in bullet points, you're writing in sentences. Okay. Then you want to do a confidence interval. We now need to say, okay, this is the confidence interval we found with this length. This means that, then we need to explain what the 95% confidence level means. And here you need to refer to the fact that you are trying to estimate what the population is. So the true average income, what is that? That is what we are estimating. And we are 95% confident that the true average income of the customers lies between this number and this number. And it's not just values, it needs to be related to the actual, what the actual variable is telling me. So it's got to do with currency. So I'm going to use a rand, and then I need to convert it to rands and what the difference, what the length of that confidence interval is. And then you're going to get your full marks. Same thing here, but now you have to deal with the non-defaulters. Same idea. And then when we want to understand if they overlap, that was very well answered. I didn't have any problems with that. I think everybody got it wrong. Maybe got it right, sorry. Maybe 2 people didn't understand what the question was related to, but that's okay. I think I gave them some pointers in the actual work. So yes, we're not trying to understand if those 2 are overlapping. It means that there might not be a big difference or significant difference between those 2 intervals that we were trying to estimate. Okay, and then when you're performing an hypothesis test for the difference between the 2 means, again, statistical notation. And here you have to make sure that you have in your test the fact that you have decided in 4.2 if your variances are equal or not. If you decided they're equal based on your test, then you have that in your code. Var that equals true. That is important. If you have it false, it's going to change the type of test that you do. Okay, whether or not your final result is the same, that's not the point. Is that you're performing a different test, and that is important that you understand you're performing a different test based on the fact that your variances are equal or based on the fact that your variances are not equal. Okay. And then you highlight your p-value here. You transfer that information over to your actual report. Full, complete sentences. What you found your p-value to be, your level of significance. Are you going to accept or reject? Not accept, sorry, reject or not reject the null hypothesis? And what does that actually mean after you've done that? Not rejecting or rejecting. What does that essentially mean for the test that you're performing? Okay, and then here, nobody, I don't think maybe one person got an ANOVA test, which is what we wanted over here. And what is, yeah, many people got this wrong. Many, probably 90% of students got this wrong. Not that it was wrong, but less wrong, less right. And this is what we wanted. Okay. Um, okay. Then you have your categorical variables. And so we wanted, some people didn't have both. If you had these tables separately, your observed values and your expected values, that's fine. If you had it together, this is actually what I wanted, as long as you had them. Lots of people forgot or didn't have the totals, and you can calculate you have the code to do the totals, right? That was important. And then your actual chi-square test. Here is an instance where you actually have a sentence for your null and alternative hypothesis instead of statistical writing, because there's no statistical notation for this explanation, right? So you're going to have to write this out, and then you perform your statistical test. And that was basically easy. Potentially everybody got this right. It's just, yeah, I was a bit lenient. If you had correct equals false versus nothing there, then it means that if you had nothing here, if you didn't have the correct equal false, it means that the default is correct equals true. And then it would have included Yates continuity in your test here. So again, that's a different kind of test that you perform. So yeah, that, like I said, I was lenient at whether you used it or not. Sometimes it gave a different answer to what was expected. But I marked whatever you have interpreted. If you interpreted the value correctly, then I gave you the marks. But essentially, this is the one that we wanted to use unless otherwise stated. Okay. And then again, we wanted to use full sentences there. Yeah, that was the one thing. Yes, go ahead.
No, sorry, I thought you were done. Sorry.
No, you can go.
I wanted to ask, was there at any point the need for us to use a Z test instead of a T test?
If you did use a Z test, I marked it correctly.
Because what happened?
Nobody was penalized for using a Z test. I didn't show you how to use a Z test.
Yeah, yeah, that's what I was gonna say now.
But
But
no, nobody was, because essentially it's difficult when you, for example, when you are when I don't know what the samples are going to look like that you select. Because when you select samples, then your sample could look like anything. You could have, for example, 5 defaulters versus 1,995 non-defaulters, right? So then it's difficult for me to see what it is. But generally, we use a t-test, even though our samples might be bigger than 30. After
So that's
30,
what I wanted to ask, right?
after 30, it becomes a z-test,
Yeah,
right?
and with
After the sample size of 30. Um, sorry, my spectacles are dirty. It become you can use a z-test because then it follows the same distribution. So whether you use a t-test or a z-test for a large sample, you'll get the same results.
okay, cool.
Okay, that's when you have a large sample. When you have small samples, however, then you cannot use a z-test for a small sample because then it performs differently. Does that make sense? So when you have a small sample, it's essential to use a t-test,
Yeah.
right? But
Yes.
when you have a large sample, both distributions behave exactly the same.
Yeah, because I I kind of tested both so
Mhm.
that I could see that I was
And it
on the
did.
right track to see that the
And what
value,
did you find?
it was very similar. Like it was
Yeah,
off by like 1 point maybe.
yeah, exactly. So after a sample size of 30, then your t-test is basically the same as a z-test. It's just that the t-test has degrees of freedom which it takes into account, which the z-test does not. But other than that, it still behaves exactly the same. The tails might just be slightly fatter for t distribution, but it's negligible. Okay, so yeah, unless you have very small samples, you can use a t-test for both. You cannot use a z-test for both. Does that make sense?
Yes, it does.
Okay.
I just assumed that the data that you gave us was the actual population. And so, because there's that validation to say that if you know I think the average of your population, then you should use, and your sample size is bigger than 30, then you should use a z-test. But I think always assume that you don't know the population kind of average.
No, it's the problem is not when you have a large population. The
Mm,
problem is when you have a small sample.
okay.
That's the problem.
But the
So
t-test is so
you
much easier. So I guess like it's a lot better to use the t-test, and that you should always use the t-test, right?
the t-test you can use for both, but
Okay.
the z-test you can't. So it's almost like t-test is the default, and yeah, okay. That's why I just showed you the t-test.
Okay, thank you.
Not to say that the z-test is wrong or anything wrong with it. It's just the problem is when you have a small sample, that's where the issue comes in. So you have to use a t-test. So if you have one sample that is smaller than 30 and one sample that is larger than 30, then what do you use?
T-test.
Yes. So yeah, I think that's just why I showed you how to do the t-test. It's almost like I didn't want to mess with fate. Not mess with fate.
I still
Jinx.
managed to go in the other direction.
Yeah, but no, but going. I mean, you didn't. It wasn't wrong.
Yeah, but I made my life so much harder because the t-test is so much simpler.
Ma'am, I think the one issue, like I remember, I'm not sure if it's Yusuf, like we're having conversations because in the assignment it talked about population. And I remember that you only used the Z test if you know the population and can actually calculate, I think, either the standard deviation of your population. So that's why I ended up using a Z test because of that. Because in the assignment brief, it talked about, taking a sample from your population. So in my mind, I told myself that the original data that you gave us is not from is not a sample from a larger population set. It is the actual population data.
But I think we read that into that too much because it made our lives so much harder.
Yeah.
made my life so much harder because I was struggling to find that Z test.
Oh
Um,
yeah. Because at first I used the t-test, but then we actually like discussed it if we should use a t-test or a z-test. And then I ended up just reading the whole project brief, especially I think on question 2, where it says select 20% random sample from the original population. So that's why I just ended up switching from a t-test to a z-test at the end.
For which thing now? We had to
I
do
think it was for question.
this question two, if you just go up,
I think it was for question 4. Was it right? Yeah, I think question 4. 4.6, if I'm not mistaken.
using a sample.
no. So what we read into, if you used to go up to question two, in that high description there,
Yes,
it says,
yes, from the original.
yeah. So we assume that the data that you gave us was the original population, and because when you do a Z test, you have the standard deviation of the population. And so when we read through the notes that when I read through the notes, is that when you have the standard deviation and your sample size is more than 30, then you would use the Z test. And if it's more than 30 and you don't know your standard deviation of your population, then you use the T test. That's why I went down that route, yeah.
Yeah,
Of
that's
the
why I
Z
also
test.
use a z-test because
Yeah,
of,
so I think,
yeah,
yeah, we
Okay,
did do that.
but it is correct, guys. It's not that
okay,
it was incorrect what you did.
Yeah, but
okay.
it's just that it made our lives harder for no reason. So let's just use the T test rather.
Okay, but you guys did the right thing.
Oh, okay.
You were not marked down for doing it. You did the right thing and you got the right results.
Okay.
So yes.
I just think it's a hard pill to swallow that we could have just used the T test, to be honest.
Okay, that's the thing. Okay, cool. Okay. Does anybody have any questions? Yes, go ahead.
Okay, ma'am. I don't know if you clarified it when you started the lecture because I joined a few minutes later. When can we expect, ma'am, the marks for assignment 2 and probably Chem?
Oh no, nobody asked me that, but I did say hopefully by tomorrow.
Okay, thank you, ma'am.
But I also said that everybody did better in assignment 2 than in assignment 1. So if you did well in assignment 1, you can expect better marks for assignment 2. So I hope that's positive for everybody. It also looks like, the marks this semester are really good. So I'm very happy. I'm very proud of everybody. Yeah, the marks look really good. And if you looked at your online test marks, also like really, really, really good. So that's all positive things. I don't have anything that I'm concerned about, really. I think there were only 2 people that failed the first assignment, and they did much better in the second assignment. So, yeah, I'm not. Yeah, I'm really. Even though I'm giving you lots of pointers, it and it might not sound. I don't know if it. I hope it's coming across. I hope it's not coming across that I'm disappointed. If that can anything. I am very happy with the way you guys have answered your assignment, both assignment 1 and assignment 2. You guys didn't have any reference point, and I'm happy with what you guys turned out. So, my pointers this evening was just to help you a little bit further so that you can have a better experience when you're writing your final exam. You guys are on the right track. You are doing the work. I'm very happy with the research that you've done, especially for assignment 2. in answering those diagnostic questions. I'm very happy with what you guys have been doing. Your participation also, I think, has been really good this semester. So, yeah, I'm confident you guys are going to do really well in the exam. If the assignments are anything to go by, I'm quite confident that you guys are going to do well. So, yeah, if you have anything else, please don't hesitate. Send me an email. We can make a plan, have a discussion. On Thursday, we're going to do. Oh, you want the answers? Sorry, did I miss some questions? Carlo, if there's load shedding, you are not allowed to submit late. Unfortunately, oh, let me just reiterate quickly. Your exam is going to take place on the 26th of May, right? I will give you more instructions as we go along next week, probably. But it is an official university exam. It is on the official university exam timetable. So, official exam rules have to apply. You will have access to your paper at 9 o'clock the morning on the 26th, and you need to submit by 5 o'clock the same day. If you submit late, it will not be marked. And it's not because I'm trying to be funny or strict or anything like that. But if it was in a normal exam and you are writing on campus, they will not allow you to submit late, right? So having this, when you send emails, there's a timestamp on those emails. And if you if you go over that time, it is not going to serve you very well. It's not my choice, but that is just what the rules are. And you guys have to, there's no more load shedding that can be used as an excuse. Okay? And it doesn't even matter that it's a real excuse. But make sure that you have enough data for your whatever devices you need to use. Make sure that you have charged your phone. Make sure you charged your laptop if you're using a laptop. Make sure that you have done everything that you need to do so that that day you can work properly. You are not distracted by anything. If you know that there's going to be load shedding in your area, you have to go somewhere else to go do your assignment. Not your assignment, your exam. It is expected of you that we have all learned from COVID and load shedding and all of those things. And we all have things in place. If you decide to work from home for your exam, you need to make sure that you have all the tools in place at home so that you can submit on time. And if you don't have those things in place at home, you have to go to campus because campus has the facilities available for you, so that you can work without interruptions at campus, and submit on time at campus as well. And if you can't get to campus, then you're going to have to go to your friend to submit on time. You're going to have to go to your cousin, your auntie, your neighbor, the church, the shop on the corner, the somewhere, wherever. You have to make a plan. That's your responsibility. And like I said, if you can't do that, you have to go to campus. Okay? Yes, Maketsi?
Ma'am, I don't know if you already said this, but are we submitting the same way we've been submitting the assignments, or this time only Canva?
Um, um, I've been thinking about submitting on Canva, but my papers have already been uploaded, and on the paper, the exam paper, it says you must email it to me. So let's just leave it at that because I don't want to have confusion. So you have to email it to me.
Okay, thank you.
All right, I'm going to stop.
And I'm
it.
assuming also you would just want the same structures like the assignments.
I will give you all of those details next week.
Okay, okay. Thank you.
Alrighty.